Hi everyone, welcome to AI Exact channel. This is Akash Yangmar and today I'll be studying Indefinite Integrals lecture 4. So basically this is the last lecture and we'll be covering up biparts and partial fractions. So let's look at the definition of biparts first and why should we use it? Why should we need it? Right? So basically let's say we have a case. If we have a case f1x dot f2x dx. Now, both of these functions are not related. For example, they're not like sin x cos x or x square plus x cube, something of that sort. They're not like that, right? They're not related. Something of e raised power x into cos x or maybe x into ln x. In that case, we don't really know any kind of substitution that would reduce that particular integral into a simpler version, and we can take the help of standard integrals to finally get to the answer. We cannot do that. So in such case, we use this kind of formula. It's kind of product rule for integration. Just like we had product rule for differentiation, this is product rule for integration. Now, how to do it? So basically, we take one function as first function and the other function as second function, and then we apply this formula. That is first function into integral of second function minus integral of derivative of first into integral of second. So this is the formula. We won't be looking at the derivation because that's of no use to us. We'll just see the application of this formula. Now there is a term called isolate. I usually call it as isolate 1. Why? Because I keep 1 as a function as well in this particular series. So I stands for inverse, L for logarithmic, A for algebraic functions, T for trigonometric, E for exponential, and 1 as one number as a function. Now, how to utilize this and what is the relation of this isolate with biparts? So basically, if we go in this order, then we won't be using inverse trigonometric function as the probable second function, right? Because we have to, in the formula itself, we have to integrate the second function. So inverse trigonometric functions are the difficult most to integrate, right? And we actually don't know how to integrate them without any kind of substitution. So this would be the least priority order. So basically this has the highest priority to take it as a first function. So this is the decreasing order in which we'll take these functions as the first function. So basically if we have inverse trigonometric function and algebraic function in the integral, let's say this is I and this is A. So we'll take this I as the first function and this is the second function. Or let's say we have algebraic function and exponential function. Let's say we have algebraic function and exponential function. In this case, we'll take this as first function and this as the second function. Why we are doing that? Because exponential functions are very easy to integrate. So that's why we are taking this into the second function because we have integral VDX, integral second function. So to utilize this formula properly, we are doing this, right? Now, there are few exceptions of this particular formula, but in 99% of the cases, you have to use this formula and you have to use this order. Now, sometimes what happens is we don't have any second function over here. Let's say we have just ln x dx. In that case, we'll assume 1 over here and then we will integrate. Now, we have logarithmic function as the at the top of the series. So this is the second function and this, no, not this is the second function. This is the first function and 1 is the second function because 1 is very easy to integrate, right? So that's how we have to use this particular series. Now let's look at certain examples. So what are standard questions? Standard questions, as I discussed earlier, like we'll be given two functions, multiplication of two functions, and we have to integrate them, and we have to use the isolate table or isolate series to decide which function is first and which function is second, and then we have to integrate it. Let's look at one example first. So this one is x cos x. So let's write ILA TE and 1. We don't have 1 over here, but still we can write it. So we have been given x cos x dx. Now, x is an algebraic function and t is the trigonometric function. So basically, in this case, what we'll do, we'll take cos x as the second function and x as the first function. Because why? Because a is before then t. So trigonometric functions are easier to integrate as compared to algebraic functions according to this table. So that's why we have kept x as first function and cos x as second function. So this would give me first function into integral of second, first function into integral of second, integral of cos x is sin x, minus integral of derivative of 1, that would be 1, into integral of cos x, that would again be sin x dx. So this eventually becomes x dot sin x minus, and integral of sin x would be minus cos x, so that would become plus cos x plus c. So this would be your answer. That is a very standard problem, and such a kind of problem has been asked in PGDBA. So that is the kind of difficulty you are going to get in the PGDBA examination, not very difficult exam questions. Now let us look at one more example. So over here we don't have a second function. So what we'll do, we'll take 1 dot ln x dx. Now this is obvious that this is our second function and this is our first function. So first function into integral of second minus integral of derivative of 1, that would be 1 by x, into integral of second, that is x dx. This gets cancelled out. So this becomes x ln x minus just x plus c. So this is our answer. Now let us talk about case 2, recurring by parts. Now sometimes what happens is, let's say we have this integral I f1x dot f2x dx. What happens is we keep on integrating this particular integral with the help of y parts, but it generates one more function that is again can be integrated only with the help of y parts. We again integrate it and we get one more function that can only be integrated with the help of y parts. So basically it keeps on going. So how to solve these kind of in recurring by part integrals? So there is a way that after 2 or 3 integrals, you will see the formation of minus I over here. So basically I equals to, we got, let's say, hx over here plus gx over here plus kx over here, and we also got minus I over here. So this will get clubbed over here and we'll get 2I equals to h plus g plus k. So I equals to this by 2. So this is how we have to proceed. This is the step-by-step process for recurring by parts. Now let's look at this with the help of an example. Now the first thing is, before proceeding forward, the first thing is we'll get these kind of recurring by parts only in the case of e raised power x into cos x or e raised power x into sin x. So basically trigonometric function multiplied by exponential function. If we are getting that kind of question, then probably we are going to get a recurring by part. So let's solve this one. I equals to integral e raised power x dot cos x dx. So this is first function, this is second function according to our Eilert rule. So this becomes first function into integral of second minus integral of derivative of 1, that would be minus sin x, this becomes plus, into integral of second, that is e raised power x dx. Now you can see that we have got one more function along with this function. So this again has to be solved with the help of by parts. So let's call it as I dash. So I dash equals to integral sin x dot e raised power x dx. Again over here we have this as second function and this as first function. So first function into integral of second minus integral of derivative of 1, that would be cos x, into integral of second, that would be e raised power x dx. Now you can see that we have got minus I once again. So basically I equals to cos x plus I dash, right? I dash is not cos x dot e raised power x plus sin x dot e raised power x minus again I over here. So 2I equals to e raised power x c plus s, and I becomes divided by 2 plus c. So this is the answer. So this is the very standard question for recurring by parts. Now there are certain special cases, but I'm not sure if we are going to get these kind of questions in the examination, PGDB examination. We can definitely get in JE or JE mains, but we are not really sure if we can get these kind of questions in the PGDB examination. But we'll see the difficult most part over here, and that is the maximum kind of difficulty you can expect in case of indefinite integrations, right? So let's see what is the special case and how to solve them. So the first case is integral e raised power x fx plus f dash x dx, and that would reduce to e raised power fx plus c. So let's see the derivation of first one. So we have e raised power x fx dx plus integral e raised power x f dash x dx. Now, according to our ILATE rule, we would have taken e raised power x as the second function and f dash x would be the first function, because we don't really know what kind of this function, but we definitely know that e raised power x comes in the end of the ILATE table, right? But over here, we'll not be following ILATE rule. I'll tell you the reason why. So this is the first part and this is the second part. We'll solve the second part first. So this is a, let's say this is I. So I equals to integral e raised power x f dash x dx. So over here, this is our first function and this is our second function. So this gives me first function into integral of second, that would be fx, minus integral of derivative of one, that would be ex, into integral of second, that would be fx dx, right? Now you can see that this becomes this with a negative sign. So this and this gets cancelled out. So I becomes e raised power x fx. So this is the only special case where we don't actually follow the ILATE rule, and it's written in this particular format. It would be better if it's written in this particular format. Otherwise, you might not be able to find out that you don't have to use ILATE rule in a conventional manner over here, right? You can do the similar kind of derivation for second one. I'll leave that to you. Now let us look at few questions that might probably be asked in PGDBA examination in the worst case. I'm not really sure if they're going to ask these type of questions, but just in case, in the worst case, they can ask, then these are the kind of questions, or these are the difficult kind of questions they can ask in the examination. So let's look at it. So before going forward with the question, what kind of triggers or what kind of thoughts I should have that I have to apply this particular process and not the regular ones, right? So first of all, I can clearly see that there is no specific or standard substitution available over here. Even if it was the case of 1 plus x square, not 1 plus x whole square, even if it was the case of 1 plus x square, then it would have made sense, because in that case, we would have taken x square as t and we would have clubbed x dx in dt, right? That would have made sense. But over here, we cannot really see that kind of substitution. Now, secondly, the other option is regular by parts. Even in that case, we'll do e raised power x multiplied by x plus 1 by x whole square. And this becomes really difficult to differentiate, because in the second part of the integral by parts integral, we'll have to differentiate this one. And that is not really easy to apply quotient rule in the inside the integral. So whenever you see this kind of difficulty in applying by parts, then your thought process should be to find out a way to convert this into fx plus f dash x into e raised power x. And also, having e raised power x in the question, that should also trigger one thought that you have to apply this kind of process. So let's see how it goes. This is e raised power x and we have x divided by 1 plus x whole square. Now what I can do, I'll add and subtract 1. This becomes 1 plus x whole square and this becomes minus 1 plus x square. Now I can clearly see that this becomes e raised power x 1 upon 1 plus x minus 1 upon 1 plus x square. So this is fx and this is f dash x. So this is a very standard approach to these kind of questions. Now let's look at this one. This one is a little trickier. So over here again, I can see that kind of thing, that kind of situation. We cannot do substitution. We cannot do anything else. So we'll take e raised power x outside, and this gives me x square. What I'll do, I'll add and subtract 4, because we have x plus 2 in the denominator. So this would give me x plus 2 whole square and x plus 2 whole square. Now e raised power x multiplied by this will give x minus 2 x plus 2, and 1 x plus 2 gets cancelled from here. So I'll be getting x minus 2 divided by x plus 2 plus 4 upon x plus 2 whole square. Now if you have differentiated a lot of functions and a lot of these kind of functions, then you will probably get the trigger that this is nothing but the differentiation of this function. So you will see x plus 2 multiplied by x minus 2 dash, so that is 1, minus x minus 2 multiplied by x plus 2 dash, that is 1, divided by x plus 2 whole square. So this is nothing but 4 by x plus 2 whole square only, right? If we differentiate this particular function. So this again becomes fx plus f dash x, again becomes the standard format. Now the third example is, now here you have to do certain kind of substitution. So the obvious substitution is the argument. So ln x equals to t. So basically x equals to e raised by x and dx equals to e raised by x dt, right? So this becomes sin t plus cos t multiplied by e raised by t dt. Again, this becomes pretty standard. This is fx, this is sorry ft, and this is f dash t, right? So this becomes standard one. So these are the three kind of examples, and similar kind of examples you can get in the examination in the worst case. Now let us talk about partial fraction basics. So until now, PGDB hasn't asked any question based on partial fractions concepts. So what we'll be doing, we'll be just touching upon the basics as of now. But if time permits afterwards, once we are done with syllabus, then probably we'll touch upon the advanced concepts. But as of now, let's focus on the basic concepts of partial fractions. So why do we and how do we use partial fractions? Basically, let's say we have a function of, let's say this sort, 1 upon x plus 2 and x plus 3 multiplied by 1 upon x plus 3, right? And we have to represent this product function as a summation function. Let's say a upon x plus 2 and b upon x plus 3. Why do we want to do that? Because it's difficult to integrate this kind of function, but it's very easy to integrate these functions, right? It becomes simple ln functions. So that's why we utilize this particular approach called partial fractions. Now I'm assuming that every one of us know how to convert this into a different series, because we have studied different series in the arithmetic progressions. So this would be nothing but 1 upon x plus 2 minus 1 upon x plus 3. That is a very basic example. But how to solve them with the help of this kind of formula? So let's see the approach, because in certain cases there will be multiple products over here, multiple factors over here. In that case, we'll have to apply this particular formula and not the intuition ones, right? So let's see how it goes. So I'll just cross multiply things over here. That would give me a times x plus 3 plus b times x plus 2 divided by x plus 2 and x plus 3. This is nothing but 1 upon x plus 2 and x plus 3. So this gets cancelled out. Now we know that numerator is nothing but 1. So what I can do, I can keep now this particular identity holds for every value of x, because we are representing this function as this function. So for certain values of a and b, this particular identity should hold for every value of x, right? So what I'll do, I'll keep first x equals to minus 3. So that would make this a 0, and this would become b equals to b times minus 1 equals to 1. So b equals to basically minus 1. Similarly, if I keep x equals to minus 2, x equals to minus 2, in that case this will become 0, and this will become a times 1, a times 1 equals to 1. So basically a equals to 1. So this is how you have to solve this factors factors a and b. So this was actually a type 1 like simple linear function, linear products. So let us look at one example. So in this question, we have three factors over here. In the previous example, we saw that we just had two factors, and intuition would have worked over there. But over here, we have three factors over. So we'll use the formula over here to calculate the values of a, b, and c. So this is 1 upon x plus 1, x plus 2, and x plus 3 equals to a upon x plus 1 plus b upon x plus 2 plus c upon x plus 3, right? Now we'll cross multiply it. We'll be getting a times x plus 2 x plus 3 plus b times x plus 1 x plus 3 plus c times x plus 1 x plus 2, and divide by this x plus 1 x plus 2 and x plus 3. Now this gets cancelled out, and we know that this summation should be equals to 1 for every value of x. Now what I'll do, I'll start plugging in values 1, 2, and 3. Minus 1, minus 2, and minus 3. Sorry, right? So for x equals to minus 1, this becomes 0, this becomes 0, and for x equals to minus 1, this becomes This is 1 and this is 2. So 2 into 1 into a equals to 1. So this gives me a equals to half. Now for x equals to minus 2, this becomes 0, this becomes 0, and this is minus 1 and this is 1. So b into minus 1 equals to 1. So basically b equals to minus 1. And let's now the third case is x equals to minus 3. For x equals to minus 3, this becomes 0, this becomes 0, and this becomes minus 2, and this becomes minus 1. So basically c is also half. So we have got the factors. Now you can just apply these factors over here and do the standard integral. Right? So this, I think this is the maximum difficulty kind of question in partial fraction they can ask you in PGDB examination as of now. But definitely we'll be touching upon the advanced concepts once we're done with the syllabus. So today's lecture was till here only, and this is the end of indefinite integration. And from tomorrow onwards, we'll be starting with definite integrals. Definite integrals won't take much time because there are few properties which you have to understand, and only property-based questions are going to come in the examinations. So that will, I think, that will hardly take 2 to 3 lectures, and we will be done with the entire calculus after that. Post that, we'll be starting with coordinate geometry. So let's meet tomorrow. Thanks for watching.